We are ready now for problem 40 on this test review. The next few problems are going to be using some formulas where we're trying to find the trig function of either the difference or the sum of two angles. And for each one of these, there's a specific formula. It's actually on the formula sheet I've given you. Right here, sum or difference of two angles. So I'm going to be referring to this as I work through these problems. Don't think they're horribly difficult initially. It's just a matter of following the formula. So the first one, number 40, says the cosine 5 pi over 4 minus pi over 6. So we're trying to find the cosine of a difference. So when I go here, cosine of a difference, looks like it's cosine u cosine v. So the cosine of the two functions plus the sine of the two functions. So therefore, cosine of the two functions plus the sine of the two functions. Cosine of 5 pi over 4 is negative square root of 2 over 2. Cosine pi over 6 is square root of 3 over 2 plus sine of 5 pi over 4 is negative square root of 2 over 2. Sine of pi over 6 is 1/2. So now you multiply two fractions, you multiply the tops and the bottom. So this would be negative square root of 6 over 4 plus negative square root of 2 over 4. I can combine this into one fraction. And that should be the answer. I want to confirm it. I shouldn't make any mistakes. And that is correct. 41. Cosine of pi over 3 plus pi over 4. So now I have the cosine of the sum of two angles. So I go to my formula. Cosine of the sum of two angles. So it's cosine cosine minus sine sine. So cosine of pi over 3 times cosine of pi over 4 minus the sine of pi over 3 times the sine pi over 4. So these are all special angles. So I know these. I think I've got them memorized. Cosine of pi over 3 is 1/2. Cosine of pi over 4, square root of 2 over 2, minus the sine of pi over 3 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2. Square root of 2 over 4 minus square root of 6 over 4. If you make it one fraction, square root of 2 minus square root of 6 over 4. All right. So far, these are maybe not too difficult. Just follow the formula. 42. Sine of 45 degrees minus 30 degrees. So it's same thing, except now we just have our angle in degrees. Now look for the equation for the sine of the difference, which is here. So it's sine of u cosine of v minus cosine of u sine of v. So it's sine 45 degrees times a cosine of 30 degrees minus cosine of 45 degrees times the sine 30 degrees. Sine of 45 is square root of 2 over 2, cosine of 30 square root of 3 over 2 minus cosine of 45 square root of 2 over 2. The sine of 30 is 1/2 square root of 6 over 4 minus square root of 2 over 4 square root of 6 minus square root of 2 over 4. Continuing on, 43. Tangent of pi over 6 plus pi over 4. So the equations for the tangent. It's a little more messier, it's like a fraction. So tan u plus tan v over 1 minus, so tangent of pi over 6 plus tangent of pi over 4 over 1 minus tangent of pi over 6 times tangent pi over 4. So tangent of pi over 6, think of sine over cosine. So it's got to be 1/2 over square root of 3 over 2. So it's 1 over square root of 3 plus, the tangent of pi over 4 is just 1. So 1 minus tangent of pi over 6, 1 over square root of 3 times 1. So I probably need to try and simplify this. So this numerator, if I get a common denominator here, this is going to be 1 plus square root of 3 over square root of 3. And here I would have square root of 3 minus 1 over square root of 3. These square root of 3s are going to cancel. Let me write it this way, square root of 3 plus 1 over square root of 3 minus 1. I believe that should be the answer, and that is correct. All right, 44 now. Throw in a little bit of a twist. The cosine of the inverse cosine square root of 2 over 2. That's inverse sine. So these are actually two angles. I'll call this theta 1 and this theta 2. I can figure these out because these are special angles. So inverse cosine square root of 2 over 2. What's the angle with the cosine square root of 2 over 2? I know that that is pi over 4. Inverse sine is square root of 3 over 2. What's the angle where the sine is square root of 3 over 2? Now I can approach this two ways. First, I can add these together, and maybe there's a chance this is a special angle. I know the cosine. If it's not a special angle, then I'm going to have to use my difference formula. So let me just say, let me think, what if I add these together? Common denominator 12, this would be 3 and 4, 7 power over 12. It's not going to be a special angle. So I think I'm going to have to go back and now use cosine, the sum of two angles. Cosine, cosine minus sine, sine. So cosine, cosine minus sine, sine. Square root of 2 over 2 times 1/2 minus square root of 2 over 2 times square root of 3 over 2, square root of 2 over 4 minus square root of 6 over 4, square root of 2 minus square root of 6 over 4. And that is correct. All right, not too bad. $45. Looks like the last one, but a little bit of a twist. It's going to make a little more work involved. The sine, the inverse cosine of 1/2 plus the inverse sine 3/5. Once again, these are angles. Now this is a special angle. So I can say that what angle is the cosine 1/2? Pi over 3. Now this one, 3/5, is not, it's not going to give me a special angle. So what do I do? Well, let me write it like this to make it clear what I'm doing. Let me just, instead of writing these inverse trig functions, let me just call them theta 1 and theta 2. And we actually already know theta 1. It's pi over 3. However, we don't know theta 2. So we got to figure out what we're going to do about theta 2. Let's do this. Let's go ahead and get our formula for the sine when you add two angles together. Because once we have this written out, we can see what we need to figure out. So if you're not quite sure why I'm doing this right now, you'll see in a minute. So the sine, if you add two angles together, sine, cosine, plus cosine, sine. So sine pi over 3 times cosine theta 2 plus cosine pi over 3 times the sine theta 2. So I need to know cosine theta 2 and sine theta 2. So here's what I'm calling theta 2. Now, based upon this, we've done this before. When I'm trying to find the inverse sine of 3/5, another way to think about that, and let me do it sort of down here out of the way, is to say, another way to think about this in my head. So this isn't always a true math rule, but it's okay to do it this way for what I'm trying to do. So we've done this before. When you have a trig function, it's the same idea, the same thought as, the sine of theta. Because when I do it this way, like I've done before, I can use that to build a right triangle for theta over 2, right? So kato is so, opposite over hypotenuse. Pythagorean formula says this is 4. Here's why this is helpful, because up here, I can put in 3/5 for sine of theta 2, cosine of theta 2 from this triangle. So ca 4/5. So now I've got everything I need. Sine of pi over 3 is square root of 3 over 2. Cosine of theta 2 is 4/5. Cosine of pi over 3 is 1/2. Sine of theta 2, 3/5. So I have 4 over 10, which reduces down to 2/5. So 2 square root of 3 over 5 plus 3/10. If I tried to put them all over one fraction, it'd be 4 square root of 3 plus 3 over 10. So what I did here, I made this a common denominator, right? I multiplied by 2 over 2. So that gives you 4 square root of 3 plus 3 all over 10. All right, 46. Now something a little different. Let me just show you what it says, and then we can simplify sine of 2x times cosine of 5x minus sine of 5x times cosine of 2x, and write as one term. So as one term, I think they mean like one trig function. So let me just write this down, and then let me show you what they're getting at. Sine of 2x times cosine of 5x minus sine of 5x times cosine of 2x. It's almost like we're using our formulas backwards. By that I mean, I'm going to go look at the cosine and sine of adding and subtracting angles. Because if I call like 2x u, I could think of this as like sine u, and if I call 5x v, sine u cosine v minus sine v cosine u. So if I go on the sheet, I want to see which of the formulas has sine u cosine v minus sine v cosine u. So first of all, here's the list. It's got to be a minus. So it's going to be this one or this one. Well, this one's cosine, cosine minus sine, sine. With me, it's sine, cosine. I mean, they're different. It's sine and cosine. So I'm pretty sure it has to be this right here. Sine of u minus v is sine u cosine v. Sine u cosine v minus cosine u sine v. Order's a little bit different, but multiplication doesn't matter. So basically this thing equals the sine of u minus v. Now basically, I'm calling 2xu, I'm calling 5xv. So I can say sine of u is 2x minus v, which is 5x, So this all reduces down to really sine of negative 3x. Now, this is something I haven't emphasized in class, but anytime you have a sine, you have a negative inside of a sine. If you look at the answer key, you can just bring that negative out. You can't do it with cosine, but that's one of the rules about sine. And the reason I do that is because this is the answer key. All right, we're coming down the home stretch. We got like 4 more to go, although these 4 are pretty involved. So actually, let's stop this video now, and then we'll do the last 4. The last 4 are double angles, half angles. So I will stop now, and then we'll come back and finish up.